Welcome to Snack and Study, where Freddie's still not allowed to talk and Reese forgot to go out.
Yeah.
Okay, so we'll finish up this lesson with power. We talked a little bit about type 1 and 2 errors the last lesson. And we discussed what power is. Does anyone remember what power is?
Yes.
When you're correct and rejecting.
When you reject and you're correct. So you correctly reject.
Feel the power.
So it's the probability that the test will reject the null hypothesis when the alternative is true. So in practice, we carry out the test in hopes of showing that the null hypothesis is false. So remember, the whole point of a hypothesis test is to prove the null hypothesis wrong. That's our goal. So when we do that and we achieve our goal, we have all the power. So here is the chart again. I do want you to memorize that. You put power in the blank of correctly rejecting. Here it is. So I do want you to memorize this chart. It's going to be helpful on the test, maybe when you get your test next class, to put it at the top, like right whenever I hand out the paper or hand out the test, just kind of draw that chart at the top. And then once you have that drawn, then you can refer to it throughout the test.
Oh, that would be helpful.
Yeah, so you'll just have it.
Think about it, and it's a long.
Yeah, so if you have the chart, you can always refer to that.
What?
Okay, so here we have an example, and it says, suppose that the student body president at a university is interested in studying the amount of money that students spend on textbooks each semester. The director of financial aid services believes that the average amount spent is $500 per semester and uses this to determine the amount of financial aid for which a student is eligible. The student body president plans to ask each student in a random sample how much he or she spends, and here's the following hypotheses. So, president wants to get things done and wants to get people more money. So he's trying to prove the $500 wrong. So he thinks that it's more than that. And so here is this picture represents, so this orange normal curve represents represents the null hypothesis. So the center is at 500. That's what it is currently. And so if the true mean is greater than 500, so here we have, I'm going to highlight, this is like the null hypothesis right here, this normal curve with the 500. If the true mean is greater, then we should reject, but if the true mean is only a little greater, then the sample mean may not be, like we may not have enough evidence to reject. And so when do we reject the null hypothesis? When the p-value is what?
Greater.
Less than alpha.
Reject. Oh, well, no,
We
reject.
reject.
Is good.
So when the p is low, reject the ho. And so if we took a sample and we got like 505, we may not have enough evidence to reject because of sampling variability. So our p-value is probably going to be greater. But if we got 525, would you expect or think that there would be enough evidence to reject? Possibly.
Yes.
But would we have a greater chance of rejecting at 505 or 525?
525.
525. So the more difference there is between my null and my alternative, the greater chance I have of rejecting, because it's going to give me more evidence to prove that the 500 is wrong. So basically what this is saying is that the 525 is going to give me more probability of power than the 505. The more difference that there is between the null and the alternative, the greater chance I'm going to have power as opposed to just the 505. So the power of a test depends on the true value of the mean. Because the actual value is unknown, we cannot know the power. So a lot of times what people will say, because what's the probability of a type 1 error? Alpha. So type 1 is alpha. And that is always given to us. A lot of times on a test, what people want to do is they want to say, okay, well, if alpha is 0.05, then beta is 0.95. And that is not true. No, not true. So do not think that they are complements of each other. I'm about to show you how we solve for power and how we solve for type 2 error. But you have to solve those. So type 1 is given, and what we're about to do in the next couple slides is calculate the probability of type 2 and of power. And those have to be calculated. and they all depend on what we get for our alternative hypothesis. So before we even start the experiment, before we even take a sample, we know the probability of type 1, and it's given to us. Then the probability of type 2 and power all depends on what we get for our sample. So we have to take the sample first before we can calculate type 2 and power. So here we're back to the flu vaccine, the terrible clip art. Here's our hypotheses.
Without eyelids.
If I wanted to find the mean and the standard deviation of this, do you guys remember the formulas? The sampling distribution formulas? So remember that mu equals p, which is 0.7. The standard deviation is what? Square root. Good. So that's how I got these two numbers right here. So when you're calculating type 2 error and power, so what is the formula for type 2 error? Or sorry, what is the symbol for type 2 error? Beta.
There's a bicycle in the reviews.
And
Beta.
yes.
Like a bicycle.
Yes, because when I converted it from Comic Sans to Arial,
It made
or
it a bicycle.
it made it, yeah, because I think it's like in Wingdings or something like that. So,
Hieroglyphics.
yes.
B for
I
bicycle.
tried to catch all of those, but then I did
It's
not.
alright.
Okay, so we count the first step if you're wanting to calculate beta and power is you find the mean and the standard deviation. So that is step 1. So put step 1 next to it.
So define.
And this is calculating type 2 error and power. The probability of committing a type 1 error, makes it sound so evil, is what? This is the trick question because we don't have to do anything. It's just there.
Alpha. 0.05.
0.05. Yeah, so no calculating involved here. So I want you to circle the 0.05 and put no calculations. Trick question. Now, here's where we're going to go into calculating type 2 error and power. So, for what values of the sample proportion would you reject the null hypothesis if alpha is 0.05? So, basically, when we have our mean is 0.7, it's a less than test then at the 5th percentile, we are going to reject. So basically, I want to find what is my value at the 5th percentile. Because if I get a sample anything less than that, then I'm going to reject. So what calculator function would I use in order to figure out what this value is? Inverse norm. Inverse norm. Inverse norm, I want to find this value. So I'm going to put in the percentile. It's a less than test, so I'm going to actually put in that value, so 0.05. And then I'm going to put in my mean, which was 0.7, and my standard deviation, which was 0.0458. Yes.
So not 0.
Not 0 and 1, because we calculated the mean and the standard deviation.
So you use it.
Now, I'm going to talk about one thing. If it were a greater than test, then I would go up to the 0.95. Okay? So, greater than,
Because you need the 95%.
right.
So 95 down.
Yes.
Oh, it's down?
Well, if I got anything greater than that, then I would reject. But if it were a greater than test, then you'd want to go to the 95th percentile.
So anything less than 95 is work?
Anything less than 95, I would fail to reject. Anything greater than 95, I would reject.
So it's always to the end, I guess.
Yes, yes.
What about if it's not equal to?
You do either one. But you would have to take, so if it's a not equal to test and I still had 0.05 as my alpha, then I would go to the 0.025 percentile. So the 2.5th percentile. Because I'm cutting my alpha in half and I'm putting it on either side. I've never seen a question where you had to do the not equal to, but just in case. So if it's a not equal to, then you cut alpha in half and then you go to the half percentile. So I'm going to find that when I plug it in. you get 0.625. So what this number represents is if I take a sample, so if a sample is taken and I get this number, so if I get 0.625 or less, then I will reject.
So is that number, it's not a percentile? That number is like a...
That is a so this number represents the 5th percentile. So that means that only 5% of the samples taken get that number. So when I take a sample, like if I went out to the local hospital or something, and I took a sample of 100 people, and I got...
Someone's head of their head.
Yes, and I did that. And then I got if I got 62.5% of people that get the flu, or anything less than that, then I'm going to reject. Doesn't mean I'm right or wrong. It just means that I will make the decision to reject. No. If I took a good sample. So we reject the null and decide that P is less than 0.7 because when I took, so hypothetically I took a sample and I got 0.6. So this is all hypothetical. Hypothetically, my sample equals 0.6. This is all hypothetical. So I took a sample, I got 0.6. What is the probability of committing a type 2 error? So remember that if I get 0.625, so that's what this vertical line represents, or anything less, then I reject. This second normal curve, so this is all the population, my null hypothesis. This second normal curve represents my sample, and it's centered at 0.6.
How'd you know that?
Because when I took my sample, I got 0.6. So based upon my sample, the center of it is 0.6. Yes, because that's the mean.
Well, is P the mean or P hat?
So when I take my new sample, that my p hat is now the mean. So imagine this second normal curve, my sample, being a whole new set of data. So I need to find a mean and a standard deviation for that. The probability of making a type 2 error is all of this shaded area above, beta. So basically, I need to find the area of that shaded area. This line right here is 0.625. I know, just stay with me, just stay with me. You go back. So this line still represents 0.625. Right here. I need to find the area to the right of that.
Where did you say the PA thing came from?
That's when I took my sample.
So they just give you that?
This is like hypothetical. Yeah, they give you that.
Okay.
Yes, they give me that.
Oh, so that.
So I need to find the area to the right of that, the shaded region. I just need to now solve for the standard deviation. How do I solve for standard deviation? What's the formula? Square root
of P times 1 minus P divided by N.
Perfect. So my mean is 0.6 and my standard deviation is 0.049, and I got that from doing
Mentally calculating.
formula P 1 minus P over N, square rooted. And then to find the area to the right, I use normal CDF. So I'm going to put 2 to the 9/9 here. So if I were to write out a list of steps, just gonna maybe write this out to the side. The first step is find mean and standard deviation of population, or your null hypothesis.
It's not sub P hat or whatever.
Yeah, so mean of P and then standard deviation of P. That's where we got like the 0.7 and the 0.048. Second step is you're going to calculate P hat of where I would reject. So that's when I did the inverse norm of 0.05. Using the mean and the standard deviation. So that's calculating the value of where, like the rejection value. Third step is draw new normal curve of sample under the population normal curve. So that's where I had the 0.6 under the 0.7. You okay? We're going to do another one.
Where in here is the... Don't we have to say...
That's what happened.
Don't we have to say... Before that, we have to say that in the sample, if blah, 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 I reject, remember? Or is that not...
That's what step 2 is. Calculating the value.
Oh, but we don't... Do we not have to explicitly say
No.
that? Oh,
Step 4 is find mean and standard deviation of sample.
So the goal is to find beta.
Yes.
Okay.
And then step 5 is use normal CDF to calculate beta. We're all here.
You're not welcome.
He doesn't get to enjoy the spooky stuff.
Rest in peace.
Forever banned from Smith Just like Reese.
I'm banned from the I'm banned from the opportunity.
Okay, so these 5 steps, I've only seen this like once or twice on the AP exam. So this is not a huge topic that is covered. Yes, but we do prepare you. It could be once or twice on the test.
I'd say once.
Why would they not make us calculate the beta value?
Okay, the definition of power is the probability that I correctly reject. So if the blue shaded area is making a type 2 error, then the complement of that would be power. Like I make a correct decision. So power and beta are complements, but alpha and beta are not. So power equals 1 minus beta.
Power is complement of beta.
So power and beta are complements.
I hate writing beta.
I know, it always looks
It's a PB.
Oh, what?
P and B.
I try to be like a little stampy at the beginning.
So alpha is type 1 error. Beta is type 2. Then we have power, and then this is just being correct. This shaded area right here, but not power.
So power is anything on the opposite side of your what you found in the
Yes.
inverse norm or the
Mm-hmm.
Oh, obviously.
Okay.
Is there an easier way to find power?
No.
Dang it.
Unless they give you, a lot of times they'll give you beta, and you just have to do 1 minus to do power.
We're smarter now.
Let's do that out of the test.
Yeah. Is power a conditional probability?
Yeah.
Yes. Yes, yes, yes.
Of course it's conditional. Of course.
What does that mean?
Conditional means like it depends on what sample you got. So it changes based on,
Sampling variability.
yes. So if I took another sample and I got 0.55, like here, I got 0.55, is the probability of my power going to change?
Yes, because your beta is.
Okay, so let's try doing 0.55 now, okay? Let's get a little practice. So here we have 0.55. This is still 0.625. So what is my next step? If I'm using this normal curve right here, what do I need to do next? Okay, I need to find my mean and my standard deviation. Mean is what?
0.55.
Good. Standard deviation is what?
We're gonna have to learn
Mental
that.
Square root of
Someone calculate the square root of 0.55 times 0.45 divided by
over 100.
100 in their head right now.
100.
Always?
No, just in this
Wait,
example.
what's P?
0.55.
And
So
this
what's
is
So it'd be
it's like
0.55 times 0.45 divided
By 100. So somebody do that and tell me what you get.
wait, no, that's the
Oh, I actually do the calculator.
So you get 0.0497. So to find the probability of a type 2 error, so that's going to be this area to the right. I will do normal CDF of what? What's my lower bound?
1.0497.
No.
so like the negative 9.
0.625.
Whoa.
Because that was the value that was the rejection value right here using
and
inverse
this
norm.
is the same scenario?
Yes.
Oh.
To infinity. My mean is 0.55. My standard deviation is 0.0497. So, someone tell me what you get when you plug that in.
So couldn't you do like the negative infinity 2.65
Yeah.
since we're calculating the power?
Yes.
Power more than 2.
Yes.
Guys, I'm calling it 0.366.
What do you get?
I don't know how to do it on this calculator. It's not it.
Oh.
Where's normal CDF on the new one?
On the TI? Or
Yeah.
Raise your hand if you think JFK is the hottest president.
My fault.
Honor does.
What do you get?
Didn't you do it?
I thought you should talk to Brooks.
I thought you said you did it. I think you
I
were
did
fine.
this original one.
What year was he?
I'm trying to, I don't know how to do
I
it
know,
on
we
this
just learned
calculator.
about it,
Give me a second.
so.
Norm CDF.
Oh, here it is. I think I found it. Oh, no. FDR was not hot.
0.656.
That's not
Point
an
zero
issue right now.
0.0656.
So hot.
Good. Okay, now, what do I get for the power? I do 1 minus 0.0656.
So you get point.
You get 0.934.
That's a lot of power.
That's a lot of power. So, it gave me more power when what? What's the difference between these two?
1.
0.5.
And which one is further away from the original, the 0.6 or the 0.55?
0.55.
0.55. So, is it accurate to say I have more power the bigger distance my null is away from my alternative? The more.
More
Yes.
confident.
Yes. Yes, I have more power. Because I have a larger difference between my null hypothesis and the sample that I took. So it gives me more evidence.
Sampling variability?
Right.
So the farther away the new P is from the old P,
Yes. So the way that they describe that, the symbols that they use on the test is the absolute value of the null minus the alternative proportion. So don't be alarmed by this. This absolute value of null minus alternative proportion is just saying the difference between, so like the 0.7 minus 0.55 is greater than the 0.7 minus 0.6. That's just the symbols that they use to represent that.
So the further apart.
So I'm not going to go through this again mathematically, but if I got 0.65, what do you think is going to happen to my type 2 and my power?
Less power.
Less power.
beta. Oh wait, less power.
Less power.
Isn't it farther away though?
Power and beta are like the same.
But because 0.65 is closer
Oh,
to
it's
0.7.
Good.
So it's is it smaller beta?
Larger beta, smaller power.
Because think about it, if you're doing 1 minus 0.1, power is bigger when beta is small.
So power and beta have an inverse relationship.
But isn't that the same with alpha? Aren't they inverse?
Yes.
Then how is it not?
So alpha and power are direct relationship, and then alpha and beta and power and beta are inverse. We'll make a nice little chart here.
Bless you. What's the symbol for power? Or just power?
It's just power.
Who likes to sit a whole bunch of things up all the
So when I increased power,
Someone who can speak.
or when I increased alpha, when I increased alpha, so basically when I increased alpha, it was at 0.505, and then it went to 0.1. What happened to my power?
It increased.
It increased. So when alpha increases, power increases.
Oh.
Oh.
So alpha and power have a direct relationship. I want you to write that. Power and beta, as well as alpha and beta, have an inverse. I know, it's a lot to think about. And then the last thing, so the last thing that we could do to our sample is we could increase the sample size.
What does that do?
So here's like a sample size of 100, here's a sample size of 200.
Oh my.
So the larger the sample size, the wider it is.
No, opposite.
Smaller.
Smaller.
sample.
This is a small sample size. This is a large sample size. What happened to my power and my beta?
It got smaller.
Power bigger?
Power got greater,
Smaller?
beta got smaller.
Oh, okay, yeah, that's what I was
Wait, I gotta write
So, type 2 decreases when sample size increases. Power increases when n increases. So all of these you should have. I want you to highlight and say memorize. I'm about to show you a chart. This will be the last thing that we do. That you can also write down at the front of your test whenever you get it. So the chart of the type 1 and 2 errors, and then this chart that I'm going to show you here in a minute. But basically, the larger the size of the discrepancy, and by discrepancy, it's that thing that I just showed you that was absolute value of p sub 0 minus p sub a. Yeah, like distance between. The higher the power, the larger the significance level, the higher the power, the larger the sample size, the higher the power. So the three things that can increase power are increasing the distance, increasing sample size, and increasing alpha. Those three things can increase your power.
So just know all.
Remember that only alpha changes if you change it. Okay, so alpha only changes when you change it.
Do we ever need to change it?
No, not unless it asks you to. So alpha is never affected unless you physically change it yourself. Otherwise, it's a preset, predetermined value. The experimenter cannot control beta. It's dependent on the alternative value. So you can say what alpha is from the beginning, but you don't know what beta is until you take that sample.
Beta is determined by
The ideal situation is to have alpha as small as possible and a power as close to 1. You want your power to be greater than or equal to 80%. Yeah, you want a higher alpha or high power as possible. The best way to increase power without increasing your alpha is to increase the sample size. So the higher your sample size, the more ideal it will be, where you'll have a small alpha and hopefully a small beta and a large power. So let's identify the decision, and then I'll show you the chart, and then we'll be done. So there is sufficient evidence to suggest that the proportion of vaccinated people who do not get the flu is less than 70%, when in reality it is actually less than 70%. So what kind of decision is made? Type 1, 2, correct, power.
Flu is less, who do not get the flu? It's less than 70% when in reality it is actually 70%.
So what decision did I make? Did I reject or fail to reject? If I'm saying that it's less. I rejected, and then was I right or was I wrong? I was wrong, so that's a
You falsely rejected.
type 1. Good.
So type 1 is falsely rejecting the hope.
Yes. So I say there is sufficient evidence that it's less, when in reality it is less. So what decision did I make? I rejected.
Power.
I rejected and I was correct. So this would be correct in power.
Isn't there, so power is only when you get one.
Okay, so this is at the bottom of page 67. Here's the chart. that I want you to fill in, and I would say memorize this chart. So these are the three things that you could do. You could increase your alpha, you could increase your sample size, and then you could increase the discrepancy between your null and your alternative. And then your columns, you don't have to write out type 1 and type 2. You could write alpha, beta, and then power. So it has it written like these, but maybe when you're making your chart on the test, you don't have to. Just put alpha, beta, and power. So when you increase alpha, like if I'm increasing my significance level from 0.05 to 0.1, three things will happen. Your alpha will obviously increase because you did that, and your power will increase. So alpha and power, they are directly related, and then your beta will do the opposite. So power and beta will always do the opposite of each other. So when I increase alpha, alpha increases, power increases, beta decreases. When I increase my sample size, alpha is not affected. Because I didn't do anything with alpha, it's not affected. The only time alpha is affected is if I do something to alpha. But if I increase my sample size, my power increases, beta decreases. And if I increase the discrepancy between my null and my alternative, my alpha stays the same because I didn't do anything to it, but my power increases, my beta decreases. So memorize this, memorize the type 1 and 2 error chart, and then have those scripts memorized for type 1 and 2 errors.